Welcome to the foundational language of chemistry. This topic is all about how we communicate chemical ideas clearly and safely. You will learn how to write chemical formulae, balance word and symbol equations, and interpret the hazard symbols found on chemical containers. These skills are essential for almost every GCSE exam paper and form the basis for all chemical calculations. Let's dive in. Let's map out the core concepts. First, chemical formulae represent the elements and their ratios in a compound. For example, water is HO. Second, balanced equations ensure the law of conservation of mass. Atoms are neither created nor destroyed. Third, state symbols tell us whether a substance is solid, liquid, gas, or aqueous. Finally, hazard symbols on chemical containers alert us to risks like toxicity or flammability. These four pillars support all of chemistry. Turning to our study notes, a chemical formula uses element symbols and subscript numbers to show the number of atoms. For instance, carbon dioxide is CO, 1 carbon and 2 oxygens. A critical examiner tip: never change the subscripts when balancing equations. Changing HO to HO turns water into hydrogen peroxide, a completely different chemical. Instead, add coefficients in front of the formula. Also, use valency to work out formulae. Magnesium oxide is milligram O because milligram has a 2+ charge and O has a 2 charge. Now let's walk through the balancing process. Start with a word equation: hydrogen plus oxygen produces water. Write the symbol equation: H plus OHO. Count atoms. Reactants have 2 hydrogen and 2 oxygen. Products have 2 hydrogen but only 1 oxygen. To balance oxygen, add a coefficient of 2 in front of water, H plus O2HO. Now count again. Products have 4 hydrogen and 2 oxygen. So add a coefficient of 2 in front of hydrogen, 2H plus O2HO, check, for hydrogen and 2 oxygen on both sides. Balanced. Let's work through an ionic equation example. The reaction between silver nitrate and sodium chloride produces a white precipitate of silver chloride. First, write the full balanced equation with state symbols. Then, split all soluble ionic compounds into their ions. Notice that sodium ions and nitrate ions appear unchanged on both sides. These are spectator ions. Cancel them to reveal the ionic equation. Silver ions plus chloride ions form solid silver chloride. This is the reaction that actually happens. Watch out for common pitfalls. The number one mistake is changing subscripts instead of adding coefficients. This changes the substance itself. Always use state symbols, they often carry the final mark. When writing ionic equations, don't forget to cancel spectator ions. And for hazard symbols, make sure you can identify toxic, flammable, corrosive, and environmental hazard symbols. These appear in practical-based questions. To wrap up, chemical formulae use subscripts to show atom counts. Balanced equations follow the law of conservation of mass. Add coefficients, never change subscripts. State symbols indicate physical states. Ionic equations focus on the ions that react, leaving out spectators. And hazard symbols keep you safe in the lab. Master these fundamentals, and you'll be ready for any chemical calculation. Keep practicing, and good luck with your exams.